Okay, Rog, what are we doing here?
Here we are, sports fans. We are checking the main bearing bore diameter on a 351. Nominal diameter is 3 inches. So there's sundry different ways to do this. Basically, what you're looking to do is determine what the bearing clearance is, because you want about 2.5 thousandths on a 3-inch shaft in order to prevent any problems with bearings at high speeds. You don't want to blow the bearings out or anything like that. So you need to be sure that you have. And if you look at this, you can see it's each one of those big marks is 1 thousandths. So we got about 2 thousandths here. 2.5. So you go back and forth with this until you see the minimum there. It's just a little under 2, which is about right, because the bearing, the crankshaft itself will add another 0.5 thousandths to 1 thousandths, and that'll give you around 2.5 to 3, which is what you're looking for. And we have 3 screaming kids in the background to help you concentrate.
Watch out, little hillbilly.
So that's what we're doing now. Each one of these bearings on a 351 Windsor is you want approximately the same diameter. So bearings 1, 2, 4, and 5 are going to be identical. The shells are the same, the holes are the same, everything's the same. The thrust on a Ford is taken up with the center bearing here, number 3. Then we'll go through another video on how to line those up when you put the crank in. You take the crank and you hit the crank hard, with this being just snug, and it lines the flanges up. You can see the thrust flanges here. They got a little copper plating on them. You can see them here on the side. You probably should put a stronger light on this. But anyway, you can see the copper here, and there's little slots for the oil to come out. You want these 2 flanges lined up, see? Because when you push the clutch in, the pressure plate tries to push the crank a little bit forward. See, on an automatic car, it's not as critical. On a stick shift car, you definitely want these lined up. And that's pretty much the story.
Are these torqued to a specific spec?
These are ARP main stud bolts. They use a special steel in these. It is 200,000 pounds tensile strength, which is probably, my guess is, at least twice as good as stock. And a stud, you have to remember that a stud divides the torque. Remember, you got 2 threaded surfaces. On a cap screw, if you look at a standard cap screw, there's a head on it, and then it's threaded right into the block. On a stud, you're dividing the torque between these threads and these threads here, and you see these threads are fine. Now, fine threads take torque load much better than coarse threads. So that's why people use these ARP main studs. It makes the bottom end much more secure than stock.
Oh, thanks, buddy, for that light. That works really well.
So that you know, you don't want to be collecting sundry reciprocating parts from your backside, because it's not fun.
Yeah, that doesn't feel good.
I mean, you know, big slugs of metal in your buttocks, not fun at all.
Right.
It's like getting shot in the ass. You don't want that.
Yeah. If you'll notice too, we had to cut some of these for the windage tray.
We'll go through another video and we'll show you how you have to fit the windage tray. You can see some of these studs were cut. The pickup on a 351 Windsor that goes in a Fox body, the sump is going in the back, which is, most Fords are designed for front sump. And on a Fox body, the way the cross members are, they had to go to a rear sump. See? So we had to modify some of these ARP studs, but basically the windage tray goes on these 4 step-down studs you can see here. The center stud is for the oil pump pickup. Now the oil pump, of course, is over here, and then the pickup goes to the back, and then the bottom of the pan is over here. And we're gonna go ahead and check the rest of these bearings Then we're going to check the crank, clean the oil holes, and put the rear seal in, and put our lubricant in, and lower the dog in there, and we'll be ready to fly.
How critical is it to check bearing clearances when you're building an engine?
Bearing clearances are very critical. The reason is that if you're building a high-performance engine, you're putting 2 and 3 times the load of a stock engine. Most of these stock motors are around 150, 200 horsepower. When you start getting up into 550, 600 horsepower range, you've got to make provisions for better oil flow, more lubrication, because you got much more load. So each piston, instead of putting out maybe you say you got 8 times 3, say about 30 horse a piston roughly. So 8 times 3 would be 240 horse. That's roughly a stock motor, 200 to 240 horse. When you start getting up to 50 horse a cylinder, so 50, 8 times 5 is what, 400. 8 times 6 is 480. 8 times 7 is 420. Oh wait, what's 8 times 7? Yeah.
56.
8 times 7? That's right, 56. So you're looking at that kind of power per cylinder.
Thanks, Hillbills.
So you can see that each piston is pushing much harder than the stock one. See, and that of course puts extra strain on everything. So to make the engine live, you have to make provisions for more lubrication, so forth and so on. But we'll go through the rest of it as we progress here. But most of this stuff's pretty straightforward.
Take your time.
Take your time.
And buy the right junk.
Right.
If you can afford it.
Right.
It's
expensive. It pays to buy high quality stuff. No question.
All right. Well, we will be back when we're lowering in the crank, and we'll get that all torqued down. So we'll see you guys.
Put pistons and rings together and gap the rings, and we'll go through all that. We'll start assembling this motor and go from there.
All right.